The following information is given in connection with the series parallel circuit in the figure shown. The voltage is 48, R1 is 6, R2 is 12, R3 3, R4 is 15, R5 is 90, and R6 is 30. Calculate the total equivalent resistance of the entire circuit, the total current, the voltage drop across each section, the current through each resistor, and the total power taken by the entire circuit. So for letter A, we are asked to find the total resistance. As you can see, these three sections are in series. However, these two have parallel resistors that we need to simplify in order for us to add all of these up together. And so for the first section, which is in parallel, we say 1 divided by 1 over R1 plus 1 over R2. Next, we're just going to add R3 here. Next, since we have another parallel resistors, we say 1 divided by 1 over R4 plus 1 over R5 plus 1 over R6. And then we simply substitute the values. For the first section, we got 4. And if we rewrite the circuit, this will be the same as this. It's just that it is simplified. Same as for this section, which has a total resistance of 9. So now we have 4 plus 3 plus 9, a total of 16 ohms. For B, we are asked to find the total current. So we'll use the formula I is equal to V over R. That's 48 divided by 6, and so we'll get 3 amps. For C, we have to find the voltage drop across each section, and so we'll use the formula V is equal to IR. Note that the current we'll use will be the same for the entire circuit, which is 3 amps. Recall that the value we got in this section is 4, and in this is 9. So we'll use that as our value for the resistance. So for the first section, we have 3 amps times 4 ohms, which is equal to 12 volts. This section is 3 amps times 3 ohms equal to 9 volts. And lastly, 3 amps times 9 ohms equal to 27 volts. Now for letter D, we are asked to find the current flowing through each of the resistors, and so we'll use the formula I is equal to V over R. Note that the voltage drop in each section will be the same for the resistors, which are parallel with each other. So for the current in resistor 6, we have 12 volts over 6 ohms, which is equal to 2 amps. For resistor 12, 12 volts over 12 ohms, which is equal to 1 amp. For resistor 3, we have 9 volts over 3 ohms, a total of 3 amps. In this section, we got 27 volts, so 27 over 15 ohms, 1.8 amps. 27 over 90, 0.3 amps, and 27 over 30, 0.9 amps. For letter E, the total power of the entire circuit. We'll use the power formula, which is P is equal to IV. So that's the total current of 3 amps times the total voltage of 48, and so we'll get 144 watts.